How long in years and months will it take for an investment to double at 6% compounded monthly? This last part, where the interest is compounded monthly, indicates to us that we're going to be using our periodic compound interest formula. That formula is A equals P times 1 plus R over N to the NT. P is your principal, which is your initial investment. R is your interest rate. N is how often interest is added into the account. So this is the number of compoundings in 1 year. T is time. And A, that's going to be our accrued amount. So in our example, the question says how long. So time is our unknown quantity. We have a 6% interest rate, so R is 6% or 0.06. Interest is compounded monthly, which means interest is added in every month, so 12 times a year. And the values of A and P are not given. However, we are talking about the time it takes for the investment to double. So we're given this relationship between A and P. A will be twice P. So we're going to be able to solve for our time by substituting into the formula. So we'll substitute in A is 2P. Then we have P times 1 plus 0.06 over 12 to the 12T. We're going to start solving this by dividing by P on both sides. That's going to be P equals, not P equals, 2 equals, 2P divided by P is 2. 2 equals 1 plus 0.06 over 12 to the 12T. I'm going to bring my calculator over here and let's work out 1 plus 0.06 over 12 so we can simplify inside here. We're going to do 1 plus 0.06 over 12. And our calculator says that's 1.005. That's a nice terminating decimal. We have 2 equals 1.005 to the 12T. Now we're going to take the natural log of both sides. We have one natural log of 1.005 to the 12T. We're going to use our power rule for logarithms to move this exponent to the coefficient of the log. That's natural log of 2 equals 12T natural log of 1.005. And then we'll solve for T by dividing by 12 natural log of 1.005. So our value of T is natural log of 2 over 12 natural log of 1.005. So then we need to put it in our calculator to get an approximate value. So when we put it in our calculator has to know what is in the numerator and denominator. In the numerator here, I only have one term, and that is natural log of 2. So I don't need any extra parentheses there. But in the denominator, I have 12 and natural log of 1.005. So I need parentheses so the calculator knows that both of those things are in the denominator. So 12 natural log of 1.005, and closing parenthesis for the log, and again for the whole denominator. So we've got 11.58. So let's write a few of these decimals down. 11.5813. I think I have a decimal wrong there. Let's fix it. 11.5813. So I have an extra 1 in there. And in the directions it says how long in years and months. So this time is in years. So this is 11.5813 years. So the 11 here is referring to years, 11 years. And we need to convert this 0.5813, this is in years, and we need to convert it to months. And we convert it to months by multiplying by 12, because there are 12 months in a year. So 0.5813 times 12. I can do this in my calculator as well. I'm going to subtract 11 so I can get just those decimal places. I'm going to multiply that by 12. Now we have 6.975. So we have 11 years and 6.9 months. Now when we do the months here, you might think that you follow your normal rounding rules. If you're strictly looking at your mathematical or scientific rounding rules, you round down when you have less than 5, and you round up when you have more than 5. But this is not a typical math problem. This is a word problem. So we have to think about it in terms of the word problem. So in the word problem, we want to know how long for our investment to double. We know that it doubles when we get to 6.9. But we want to make sure that it's gotten to that double balance, so we round up. So on our months here, we're always going to round up to the nearest month. So even if this digit wasn't a 9, say it was a 4, a 3, a 2, or a 1, we would still round up. So it's going to be 11 years and 7 months. So once again, we are always going to round up on these months because we want to go longer. We need to go longer than the answer we got to make sure that our investment has doubled. How long will it take for an investment to triple if it's compounded continuously at 12%? Now the wording in the problem here, that the interest is compounded continuously, tells us to use the formula A equals PE to the RT. The way the question is phrased, how long, tells us that we're going to be solving for time. Our interest rate is 12%, and we'll write that as a decimal, 0.12. And we want to know how long for our investment to triple. This tells us the relationship between the ending and the starting amount. My ending amount will be triple the starting amount. So let's substitute this information into the formula. A equals PE to the RT. A is 3P. We have PE to the 0.12 T. We're going to solve for time by dividing both sides by P, and that gives 3 equals E to the 0.12 T. I'm going to solve by taking the natural log of both sides. Natural log and E are inverses of each other, they cancel, and we're left with 0.12 T equals natural log 3. We'll divide both sides by 0.12 to get T equals natural log of 3 over 0.12. Let's put that in our calculator. Got natural log of 3 over 0.12, and we've got 9.1. Let's see, in the directions it says to round to 2 decimal places. So we're going to round 9.16. Years. So it'll take 9.16 years to triple our money at a 12% interest rate compounded continuously. During a research experiment, it was found that the number of bacteria in a culture grew at a rate proportional to its size. At 5 a.m., there were 2,000 bacteria present. At noon, the number of bacteria grew to 2,900. How many bacteria will be there at midnight? So in this example, it tells us that the rate grows proportional to its size. And that means that we're going to use our exponential growth and decay model, which is A of t equals A naught e to the kt. A naught is our initial amount. K is our growth rate. T is time. And in this example, they're marking out the time with 5 a.m., noon, and midnight. So they're using marks of the hour, so our time is in hours. And then we have A, and A is the amount after time. With this example, we're given some information that the population is going to grow from 2,000 to 2,900 from 5 a.m. to noon. So our population goes from 2,000 to 2,900, and our time period is 5 a.m. to noon. We want to figure out how much time has passed. So the time that's passed is going to be 6 a.m. would be 1 hour, 7, 8, 9, 10, 11, 12. That's 7 hours. So from 5 a.m. to noon, that is 7 hours. T equals 7 hours. So with this piece of information, we're going to be able to figure out K, the growth rate. So let's plug the information into the formula and solve for the growth rate. So our formula is A of t equals A naught e to the kt. So A naught is our starting population, that's the 2,000. A is our ending population, that's the 2,900. E to the k times 7. We'll start solving by dividing by 2,000. 2,900 divided by 2,000 will reduce to 29 over 20. We have e to the 7k. I'm going to take the natural log of both sides. Natural log and e are inverses of each other, they cancel. So on the right hand side we have 7k. And we'll get k by itself by dividing both sides by 7. So we have our growth rate k being natural log of 29 over 20 over, I wrote 17 there, that should be a 7, over 7. So now that we have the growth rate, we can answer the question, how many bacteria will be there at midnight? And there are two different ways to do this, depending on what you set as your starting number of bacteria. So if you start with 2,000, that's at 5 a.m. And you want to know what will the bacteria be at midnight. So from 5 a.m. to midnight, that's going to be 19 hours. Or if you prefer, you can set it up from the 2,900. So if you go from 2,900 until midnight, you're going from noon to midnight. That's only a time of 12 hours. So if you set it up starting at 5 a.m., you're going to use 19 hours, 2,000 bacteria to start, E, and you'll use the K that you just figured out, natural log of 29 over 20, over 7 times 19, or if you start at noon, you'll say A of 12 hours is 2,900 e to the natural log of 29 over 20 over 7 times 12. Let's type both of these in our calculator and you'll see that you get the same answer. So let's start with this one first. We've got 2,000 e, and I'm going to put this 19 in the front. That's our 19 hours. Natural log of 29 over 20. And then over 7. And so after 19 hours, that 2,000 bacteria has grown to 5,483. Okay, let's see the other one. So starting at noon, we have 2,900 bacteria. E, and I'm going to move this 12 to the front. 12 natural log 29 over 20. Close parenthesis for the log. And we're going to divide by 7. And you can see we've got the same answer here, 5,483 bacteria present at midnight. And I'm just going to check the directions. It says round to the nearest whole number. Okay, so we've rounded correctly here. A certain radioactive isotope is a byproduct of some nuclear reactors. Due to an explosion, a nuclear reactor experiences a massive leak of this radioactive isotope. Fortunately, the isotope has a very short half-life of 5 days. Estimate the percentage of the original amount of the isotope released by the explosion that remains 3 days after the explosion. All right, so on this one, we're going to start off using the information about the half-life to figure out the rate, the decay rate. So we're going to use our exponential growth and decay model, A of t equals A naught e to the kt. And we have a half-life. See if I can spell that right. Half-life of 5 days. So in a period of 5 days, our amount will become half of what we started with. So this information is going to allow us to figure out K, that decay rate. So we are going to use our formula. A of t equals A naught e to the kt. Let's substitute in this half-life. We're going to have half of our original amount, and that's in a time of 5 days. So we have 1/2 A naught equals A naught e to the k times 5. I'm going to divide both sides by A naught and get 1/2 equals e to the 5k. I'm going to take the natural log of both sides. Natural log and e are inverses of each other, so they cancel. I have a natural log of 1/2 equals 5k. I'll divide by 5, and I get our decay rate to be natural log of 1/2 over 5. Now once I have the decay rate, I'm going to be able to answer the rest of the question. It says, estimate the percentage of the original amount that is released 3 days after the explosion. So here, we're given a time period of 3 days. So we're going to substitute that into our formula. So we're going to substitute a time of 3 into our formula. So we get A naught, they don't tell us the initial amount, e to the natural log of 1/2 over 5 times 3. Plugging a time in, so I plugged in two things. I plugged in a time of 3 days, and I plugged in the decay rate that we just found. Now what we're supposed to do now is in our calculators input this right here. This is going to give us a percentage of the original amount. So we're going to type this in our calculator, and then we're going to turn it into a percentage. Let's get our calculator. And we're going to type E, and I'm going to move that 3 to the front. 3 natural log 0.5 over 5. And we get 0.65975. Let's write that down, 0.65975. That's not our K, excuse me, that's not our K, that's right here. So we have A naught times 0.69575. And we turn this into a percentage, and this is going to be the percentage that's remaining after 3 days. Now remember, you have a half-life of 5 days. So we're going to have 50% in 5 days. We have less than 5 days, so we still have more of that amount left, more than 50% left. So we have 69.575, and let me just look at what the directions say about rounding. It says, do not round until the final answer, then round to the nearest whole number. So let me look at my calculator real fast. Okay, I apologize. I am clearly not able to keep that many digits in my head. It's 6597. I got my digits reversed. 659. Let's say 659. 659. So we're going to round to 66. So 66% of the original amount remains at 3 days. Jimmy invests $20,000 in an account that pays 4.11% compounded quarterly. How long in years and months will it take for his investment to reach $24,000? So since interest is compounded quarterly, we're going to use our periodic compound interest formula. That's A equals P times 1 plus R over N to the NT. Jimmy invests $20,000, that's his initial investment, the principal. An account that pays 4.11%, that's our interest rate, 4.11%, and when we use it in the formula, we want to use it in the decimal form, 0.0411. That interest is compounded quarterly, so interest is added in 4 times a year, so N is 4. And we want to know how long, so time is what we're interested in finding. How long will it take for his investment to reach $24,000? So our final amount would be $24,000. So we have all of the pieces here to solve for time. Let's plug into the formula. That's $24,000 equals $20,000 times 1 plus 0.0411 over 4 to the 4t. So I'm going to divide both sides by 20,000. And 3 of those zeros cancel out. We get 24 over 20 equals, and let's see, let's type this part in our calculator to see if we get a nice round number. 1 plus 0.0411 divided by 4. Okay, so we do get a terminal decimal here, so let's write down 1.010275. Alright, I'm having a hard time with my decimals, so let's double check. 1.010275. Okay, we've got that right. And that's to the 4t. We could reduce this 24 over 20 even more. 4 goes into 24 6 times, 4 goes into 25 times. So we have 6/5 equals 1.010275 to the 4t. We're going to solve this by taking the natural log of both sides. Natural log on the left, that's natural log of 6/5. Natural log on the right. Once we introduce the log, we can now use the power rule for logarithms and bring this power to the coefficient of the log. It gives natural log of 6/5 equals 4t natural log of 1.010275. We want to solve for t by dividing by 4 natural log of 1.010275 on both sides. So we're going to get our time equal to natural log of 6/5 over 4 natural log 1.010275. Let's type that in our calculator. Got natural log of 6/5 in the numerator. Now in the denominator I have both a 4 and this natural log, so I need parentheses so the calculator knows both of them are in the denominator. 4 natural log 1.010275, close parenthesis for the log and close parenthesis for the denominator. So we get 4.4587. And this example asks for years and months, so we're going to break this apart into the 4 years plus the 0.4587. So this represents the years, 4 years. And we need to figure out the months. So let's take out the 4 years. And this is how many parts of a year we have. We're going to convert that to months. You convert it to months by multiplying by 12. There are 12 months in a year. And so we get 5.5 months. And we need to round. And we're going to round up. Now this is a very special example. And we don't follow our normal rounding rules. We're going to round up to ensure that we're reaching that $24,000 balance. But not only that, this interest is compounded quarterly. Your interest does not get added in every month. So you have to only put every 3 months because that's how often interest is added in. So we're going to round up. We're going to round that 5.5 up to 6. And we want to make sure that that is a multiple of 3 because interest gets added quarterly. That's every 3 months. And 6 is a multiple of 3. If it wasn't a multiple of 3, I would keep rounding up until I get to a multiple of 3. So in this example, it would take 4 years and 6 months for the balance of this account to reach $24,000. Now it won't be exactly $24,000. It will be just slightly above with the extra interest. What is the interest rate necessary for an investment to quadruple after 15 years of continuous compound interest? So we have continuous compound interest, so we're going to use the formula A equals PE to the RT. And we're given a time period of 15 years to quadruple. Quadruple is multiplying by 4. So that tells me the relationship between the starting and the ending amount. A is equal to 4P. And we want to know what is the interest rate, so we're going to be solving for R in this problem. Let's substitute this into our formula. A equals PE to the RT. A is 4 times our starting amount, 4 times P. And we have a time period of 15 years. We're going to solve this by dividing by P on both sides. We get 4 equals E to the 15R. I'm going to do the natural log on both sides. Natural log and E are inverses of each other. They cancel, so that gives natural log of 4 equals 15R. I'm going to solve for R by dividing by 15. So we have R is equal to natural log of 4 over 15. We'll put this in our calculator. Natural log of 4 over 15. That gives 0.0924. Let me take a look at the rounding. It says round to 2 decimal places as needed. So since we're turning this into a percent, let's see. Okay, since we're turning this into a percent, we're going to do 4 decimal places, and then we'll move it 2 places. So we have R equals 0.0924. We'll turn it into a percent and move it 2 places to the right. So we have 9.24%. So it will take an interest rate of 9.24% for our initial investment to quadruple in 15 years, compounded continuously. The population of Adamsville grew from 8,000 to 15,000 in 5 years. Assuming uninhibited exponential growth, what is the expected population in additional 2 years? Within the problem, we're talking about the population of a city, and we assume uninhibited exponential growth. That means that we're going to use our population growth formula, which is P of t equals P naught e to the kt. So this is our formula for population, and it is uninhibited exponential growth. It's an exponential model. So that's why we're using this formula. So we have that Adamsville grew from 8,000, a population of 8,000, to a population of 15,000 in 5 years. So if we assume we started off time equals 0 at 8,000, after 5 years we have a population of 15,000. Now using this information, we're going to be able to figure out K, the growth rate of this population. And once we know K, the growth rate, we can use that information to answer questions about this population. So let's find the growth rate. So I'm using that formula, P of t equals P naught e to the kt. The population grows to 15,000, starting at 8,000. E to the k times 5 took 5 years to grow from 8,000 to 15,000. And now we're going to solve for k by dividing by 8,000. And we have e to the 5k. We can do some reducing here, make this 15 over 8. Now take the natural log of both sides. Natural log of 15 over 8 equals natural log e to the 5k. Natural log and e are inverses. They cancel each other out. We get 5k equals natural log of 15 over 8. Divide both sides by 5, and we get our growth rate. Natural log of 15 over 8 over 5. And now that we know that growth rate, we can answer this question. What is the expected population in additional 2 years? And we have 2 different ways we can go about calculating this. So if we start off with 8,000, we're going to grow to some unknown population. And we want that to be an additional 2 years. So that is the 5 years plus 2 years, so that's 7 years. So we could set up our formula for a total of 7 years. We started off with 8,000. We have E, and we're going to use the K that we just found over here. natural log 15 over 8 over 5, and 7 years. Or if we start off with a population of 15,000, that's going to grow to some unknown amount, but that is only 2 years, 2 years of time. So if we do it that way, we would have P of 2. We started off with 15,000, e to the k, natural log 15 over 8 over 5 times 2. So we're going to be able to type both of these into the calculator and you're going to get the same answer. So we have 8,000 e, and I'm going to move the 7 in the front, 7 natural log of 15 over 8 over 5, and with an additional 2 years, the population has now grown to 19,288. So let me check the rounding. Round to the nearest whole number. That's 19,288. Okay, now let me show you with the other formula. If we do 15,000 E, I'm going to move this 2 in the front so it's a little easier to type. I don't need as many parentheses. 2 natural log of 15 over 8 over 5. And you see we get the same answer, 19,288. So just as a reminder of how we got here, we needed to use some of the information given to us to find the growth rate. And once we found the growth rate, we could use that information to answer other questions about this population. Benjamin and Associates, a real estate developer, recently built 190 condominiums in McCall, Idaho. The condos were either 2-bedroom units or 3-bedroom units. If the total number of bedrooms in the entire complex is 486, how many 2-bedroom units are there and how many 3-bedroom units are there? So we want to know how many 2-bedroom units we have and how many 3-bedroom units we have. So I'm going to start by choosing some variables. I'm going to let X represent the number of 2-bedroom and let Y be the number of 3-bedrooms, condos. And in the first sentence here, it says they built 190 condominiums. So I know that the number of 2-bedroom condominiums plus the number of 3-bedroom condominiums needs to equal 190. And then some more information is given. Here it says the total number of bedrooms in the entire complex is 486. So I know I can multiply 2 times the number of 2-bedroom condominiums and 3 times the number of 3-bedroom condominiums, and that should equal the total number of bedrooms in the complex. So this gives me a system of equations that I can solve. This system of equations, you can solve it with substitution or elimination. It's whichever method you prefer. The way that these equations are written right now has the x's lined up, the y's lined up, our equal sign lined up, and our constants lined up. So this is the first step in the elimination method. So I'm going to solve using that elimination method. So with the elimination method, I want to decide which variable to eliminate. And it doesn't matter which one. I'm going to eliminate the x. So I need the x variables to have coefficients that are the same number and the opposite sign. So since I have a 2 on this one, I want to make the other one a -2. I'm going to multiply -2 times that first equation. That's going to give -2x minus 2y equals, and that will be 380. 2 times 190 will be 380. The second equation can stay the same. 2x plus 3y equals 486. So now I'm able to add the equations together, and one of the variables will eliminate. -2x plus 2x is 0. That's the variable that eliminates. -2y plus 3y is y equals, and I forgot my negative, sorry about that. That should be -380. So when I subtract these, I get 106. 486 minus 380 is 106. So now we know that we have 106 three-bedroom condominiums, and I'll substitute this back in to figure out how many two-bedroom condominiums we have. X plus 106 is 190. I'm going to subtract 106, and x is equal to, we got 190 minus 106, that's 84. So we have 106 three beds and 84 two-bedroom condos. Thank you for checking out my videos. Have a great day.